Hey everyone, it's Coach K. I am going to be teaching you guys about algebraic proofs. The first one that we're going to be talking about is addition and subtraction property. And what this looks like is if A equals B, okay, then if we're doing the addition property, we're going to be going A plus C equals B plus C. So all we're doing is adding to the same thing to both sides of your equal sign. So then if we're talking about subtraction, then we do the same thing. We're going to subtract. A minus C equals B minus C. So in this part right here, for addition, you're going to add the same thing to both sides. So that's addition property. If it is subtraction, you're going to subtract the same thing on both sides. The next property we're going to talk about is the addition and division properties. So we're going to start it out the same way. If A equals B, so we started out the same thing. Then what we're going to do is we're going to do multiplication. So if A times C equals B times C, what are you doing? You're multiplying the same thing on both sides. So I'm multiplying times B or C times C. Then you can also do A divided by C equals B divided by C. But C cannot equal 0. So when we're looking at it, we're dividing both sides by the same thing. So that is division property. So if you multiply both sides by the same thing, that's multiplication property. If you divide both sides by the same thing, that's division property. The next property that we're going to discuss is substitution property. If A equals B, we're always starting at the same thing, then A, the letter A, can be substituted for B in an equation. The next property is distributive property. A times B plus C with our parentheses. Remember, distributive property is what you're going to multiply A by both things inside of your parentheses. So it would be equal to A times B plus A times C. Next one is reflexive property. Remember, this is like the hardest one ever. A equals A. It's just exactly the same thing. So when you see something that says the same exact thing on both sides, that's reflexive property. Symmetric property. If A equals B, then B equals A. So what are you doing? You are switching. You're switching the two. And the last one is transitive property. If A equals B and B equals C, what matches in both of them? The B matches. So then you can say A equals C. All right, so let's look at this first problem over here. Name the property that the statement illustrates. So how are we getting from here to here? What is the opposite of division? Multiplication. So you're going to multiply both sides right here to 2. So those cancel out. So x equals 2 times 7 is 14. So you're multiplying it by 2. So this is multiplication property. All right, so let's look at the next one. So what's the change from here to right here? What changed in both of them? You're subtracting 4. So what's happening? Subtraction property. Okay. So how did we get from here to here? We did distributive property. Okay. If EF equals GH and GH equals JK, and then EF equals JK, what matches in both of them? Right here. So we're putting these two together. So which property is that? If you said transitive property, good job. All right, let's look at this one. It says JK is equal to KL, and KL equals 16. So if KL equals 16, then JK equals also 16. This is substitution. So everywhere I see a J or KL, I can put 16. Oh, look at this one. They're both exactly the same. So if they're the same, what are they? Reflexive. Okay, so let's look at this one. PQ equals ST. So ST equals PQ. So what's happening? It is switching. So it is symmetric property. All right, let's go to the next side. A proof is a logical argument that uses deductive reasoning to show that the statement is true. We have 3 different types of proofs. The one that we spend most of our time with in geometry is a 2-column proof. Has numbered statements and correspond reasonings to show that the argument is in a logical order. The key word here is logical. You also can do a paragraph proof. Has statements and reasons of a proof as sentences in a paragraph. The last one is a flow chart. Uses boxes and arrows to show the flow of a logical argument. So we're going to work on a 2-column proof. So on this first one up here, they give us this statement right here. That is given. What we're trying to prove is x equals 3. So the first thing that you guys should put is your given. And then the last thing you put is your proof. Why did I write this statement right here? It is because they gave it to us. So we're going to write it as a given. Now, the next part. We have 3x plus 2 equals 23 minus 4x. So what is our next step? What did they do to get from this step 1 to step 2? If you look at it very closely, You are adding 4x to both sides. So what property is that? If you said addition property, you are correct. So then that gives me 7x plus 2 equals 23. So how did I get from step 2 to step 3? What did I do? I added the 3x plus 4x. What is that called? Combine like terms. Remember, they have the same last name, so you can add them together. Then what had happened from step 3 to step 4? What did you see is different? This is changed. So it looks like they subtracted 2 on both sides. So I'm going to subtract 2 on both sides. That's how I get 21. So what property is that? Subtraction property. Okay. So that gives me 7x equals 21. Then the last thing, how did I get from step 4 to step 5? Oh, you divide both sides by 7. So x equals 3. So what did we do? We divided, so it's division property. Ooh, don't ask me what just happened. All right, so let's look at this last proof. Okay, so what did they give us? They gave us this statement right here. So that would be the very first thing we put. A negative 5 times 7w plus 8 equals 30. Why did we put that? Because they gave it to us. Okay, if they give us something, then you do those first. What do we have to prove at the end? We have to prove that w equals a negative 2. So you're going to put that at the very end. You will never, ever, ever put the word prove in a proof. You will write this one all the time, a given, but you will never, ever put the word prove on a reason. So let's work out this problem. So I have a negative 5 times 7w plus 8 equals 30. So what's our first thing? We're going to do distributive property. So I get a negative 35w minus 40 equals 30. So this statement right here, I would put in my statement number 2. A negative 35w minus 40 equals 30. What did we do to get to that statement? So first thing I'm looking at is what's happening from statement 1 to statement 2. What did we do? Up here, we did distributive property. So we'd write distributive property right here. All right, what's our next step? Our next step is going to add 40 to both sides. Okay, I didn't do anything to this right here, so that gives me 35w equals 30 plus 40 is 70. So how did I get from, so that would be my statement number 3. A negative 35w equals 70. So what happened from step 1 or 2 to step 3? What did we do? If you look right here, we added to both sides, so that means we're going to do addition property. Then, what's our next step? We're going to divide by a negative 35. We're going to divide by a negative 35. Those cancel out, so w equals a negative 2. Oh, look, that's way down here. So how did I get that to be a negative 2? I did division property. All right, y'all have a great day.